Today we're going to go ahead and talk a little bit more about scatter plots and cover the same learning targets that we've been covering for the past couple days. The first one is creating a scatter plot and drawing a line of best fit, and then estimating the equation by choosing two lattice points in the line, and then interpreting the slope and y-intercept of the line in the context, and also using the line of best fit to make predictions. Couple things that I'd like to review first. Slope formula is y2 minus y1 over x2 minus x1. Should be a 1 there. And slope intercept form is y equals mx plus b. And point slope form is y minus y1 equals m times x minus x1. For the first example here, it's formatted a little differently than our normal scatter plots. And once we plot this, you'll kind of see why. So I'm going to actually skip part A for a second, and I'm going to go ahead and plot the points so that you can kind of see where they show up on the graph. So we're going to go ahead and plot 4, 250. Okay, so 4, 250, 6, 350, 8, 450, 10, 550, and 12, 650. Okay, you'll notice right away that these actually form a perfect line, okay, which we haven't had with our scatter plots before. So I'm going to go ahead and draw this line in. Okay, so there's my line of best fit. Notice that each of those points fit perfectly on that line. So this helps us answer the first question. Can this situation be modeled by a linear equation? Our answer is yes, and our reason is pretty easy, and we've actually done this before. Notice that my pattern here for my y's.
Susan Burmeyer, please call extension 3952, please. Susan Burmeyer, extension 3952.
The pattern for y's is to add 100 each time, and the pattern for x's is to add 2 each time. So we did this last unit. So our rate of change is up 100 over 2. That means we have a constant rate of change. It changes for the same rate every time. So there's a constant rate of change. Okay, so the slope is going to be 100 divided by 2, which is 50. So in this situation, that means that the cost in dollars is going to be 50 per person. Okay, so cost is $50 per person. Okay, so an equation of that, we can continue our pattern backwards like we did before. So if I go back to 2 and then 0, subtract 100, I get 1, 50, and then 50. So this is my intercept. So this goes back to the last process of finding our zeros there. So our equation is actually y equals 50x plus 50. Okay, so we have our slope here. Notice our y-intercept is at 50. That's why we have plus 50 there. And then we're actually done with that problem. Okay, so pretty easy. What I want you to do is go ahead and pause the video and try the guided practice problem. It is very similar. Once you have finished, go ahead and hit play again and check your answers for the problem you did. If you have any questions, hit pause and raise your hand. Okay, go ahead and take a second and check your answers for that guided practice problem. You can see the line at the right. There's a constant rate of change. The slope is 16, so it's $16 per person. This time our equation is 16x, and it's going to cost $1,920 for 120 people. Okay, so if you have any questions or want to take some time to check this, go ahead and pause. When you're ready, hit play and move on to the next problem. Okay, we're going to look at a situation now that doesn't work out so well. And you're going to see as we graph these. So I'm going to go ahead and plot those points. So I have negative 2, 2, negative 2, 3, negative 1, 2, 0, 1, 1, 0, 1, 1, 1, negative 1, 2, negative 1, 2, negative 2, and 3, negative 2. Okay, notice in this, we actually have a negative correlation there, meaning as my x's get bigger, my y's are actually getting smaller. Okay, once I get to this, I'm going to go ahead and draw my line, and I'm going to go right through there, I think. It's pretty close. I'm going to pick 2 points on the line. Okay, now the points don't have to be points that you already had, but I'm going to use 1, 0 and 0, 1. So I'm going to go ahead and find the slope. We're going to do 1 minus 0 over 0 minus 1. So I get 1 over negative 1. My slope is negative 1. Now I'm going to use this and one of the points to plug in and find my point slope form of the equation. So I'm going to do y minus 0 equals m, so check that, m, which is negative 1, times x minus 1. Then I'm going to go ahead and rewrite the equation in slope-intercept form. So y minus 0 is just y. If I distribute, I get negative x and a plus 2. Okay, this is the equation of the best fit line. Go ahead and hit pause if you have any questions. Raise your hand if you need any help before we go on to another application. Okay, last example we're doing, example 3. The table shows the number of active woodpecker clusters in the part of the DeSoto National Forest in Mississippi. We're going to create a scatter plot first. And notice that this doesn't match our 1992, 1993. This is the years since 1992. Okay, so, or sorry, since 1990. So 1992 is actually going to be at our 2. We're going to go up to 22. 3, we're going to go up to 24. 4, we're going to go up to 27. 5 is still at 27. 6 is at 34. 7 is at 40. 8 is at 42. 9 is at 45. And 10 is at 51. Okay, once I have that, I'm going to go ahead and draw my line. We're going to try to do this right through there. No, I don't like that line. I like this a little bit steeper. Try to get those. Okay. Not a great line. Let's try one more time. Maybe a little bit steeper. Let's try. There we go, more of them. Okay, so I'm going to go ahead and pick the points here. I'm going to use this one, which was 9:45. And then I'm also going to use this one, which is at about 14. Okay, so if I find my slope, 14 minus 45 over 0 minus 9 gives me negative 31 divided by negative 9, or positive 31 over 9, either way. So when I plug this in, y minus 14 equals 31 over 9 times x minus 0. I'm going to change this to slope-intercept form. So I have 31 over 9 times x. I'm going to add 14 to both sides to get y equals 31 over 9 x plus 14. Okay, so there's my equation of my line of best fit. So notice the process is very similar to what we did last week. Once we choose our 2 points, we're going to find our slope. And then I use my slope and this point here to plug them in for this problem. And then I distribute and solve for y. So once I get to this point, the slope represents the increase in active clusters per year. Okay, so all I did was look at my y over my x, so active clusters per year, and it's increasing. And then 2010 is going to be 20 years since 1990. So we're going to go ahead and plug that in. Y equals 31 over 9 times 20 plus 14. So 31 over 9 times 20 plus 14 gives me about 83 active clusters. Okay. Again, take a minute, look this over, make sure you have everything down and understand it. If you don't have any questions, go ahead and try the guided practice problem once you hit pause. If you do have questions, hit pause, raise your hand. Once you are done with the guided practice problem and you understand this, you can go ahead and hit play to check your answers for the guided practice. Here are the answers for the guided practice problem. You have your scatter plot and the points I chose, my slope, and my equation of my line. Hit pause so that you can look all of this over. When you're ready, hit play so you can check the bottom part. Okay, for 5 and 6, slope represents the increase in weight per week, and we predicted that the alligator would be 20.18 pounds at week 15. If you have any questions, go back and look these problems over again. If you don't understand and really need help, raise your hand and we will help you out. Once you finish, you do not have any homework today. We will have tomorrow to practice in class. Have a great day.